We have looked at trig equations before, and now we're going to revisit them. But we're going to look at these a little differently. What we're going to be looking for is, so we have sine of theta equals 1/2. What this is telling me is to find all angles where sine equals 1/2. Well, that's easy to get started because we could look at our unit circle. And on our unit circle, sine is our y value. Sine theta equals y. So we're looking for when y is 1/2. So we want to look at our unit circle, and I happen to have one handy right here. And so I'm looking for when y is positive 1/2. Well, I see two locations. But these aren't the only angles that would give me a 1/2 for a y value. So I have pi over 6 and I have 5 pi over 6, but I could also get there if I went around the circle again, or I went around the circle again. Every time I make a rotation around the circle, I'm going to hit that spot again. Remember coterminal angles. So I have the two spots that are on my unit circle, pi over 6, and I have the point 5 pi over 6. But I could hit those again. And we could hit them by finding the coterminal angles. And that was to add or subtract 2 pi. So what I'm going to do is I'm going to tack on a plus or minus 2 pi, and I'm going to put it in there. That means I could go around the circle once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, and still land at the same spot. So every time I go around the circle, a 2 pi, I land at the same spot. So to get those coterminal angles, we added or subtracted 2 pi. Now let's look at cosine. Cosine is negative 1/2. Okay, so cosine was the x value. So we're looking for when the x value is negative square root of 2 over 2. So I suggest starting with your unit circle, and we're looking for the places that have an x value of negative square root of 2 over 2. Well, that's here, sorry, and down here. So 3 pi over 4 and 5 pi over 4. But we could hit it again if we go around the circle again. So plus or minus 2 pi n. Plus or minus 2 pi n. Now the next one says tangent is 1. Well, tangent was y over x. So we're looking for where y over x is 1. Now this one can be interesting because we can do it one of two ways. Here I would have a tangent of 1 because these are identical. I would also have it here. Now, these are exactly across the circle from each other. So instead of going all the way around the circle, I only have to go halfway to hit a spot that has a tangent of 1. Half of the circle, half of the circle, half of the circle. So we can actually write on this one that I only have to go halfway around the circle to find the next one. And halfway around the circle would be just a pi. Oh no, this one we don't have sine by itself yet. So the first step is going to be get sine by itself. So we're going to try to get sine by itself. So the first thing would be to add that square root of 2 over Ooh, that's not a good color to use. Let's find a different one. Add the square root of 2 over. And that would give me 2 sine theta equals the square root of 2. Then I would need to divide by 2. And so I get sine theta equals square root of 2 over 2. Well, sine are my y values. And so I'm wanting whatever the y value is, square root of 2 over 2. And this happens here and here. Now notice they're not across the circle from each other like the tangent one was. So whenever it's sine and cosine, you will have 2 answers. And we're going to add and subtract 2 pi. So 2 answers. One of them was pi over 4. The other one was 3 pi over 4. And we're going to keep going around the circle forever and ever and ever. And so we just add and subtract 2 pi in. Next example. The next example, we have tangent squared. Okay, so we're going to get tangent squared by itself. So I would add the 3 over. And so I get tangent squared equals 3. So to undo the squared, I would square root both sides. Now, don't forget, when you square root both sides of an equation like that, you have to put the plus or minus, I'm going to put it really big, in front of that square root. So we want where tangent is either positive or negative, square root of 3. Okay, so tangent, whoops, I'm sorry, the square root would be gone because we took the square root. So to get a square root of 3, positive or negative, y divided by x, we would have to have a square root of 3 over a 1. So square root of 3 over 2, 1/2 for the x. Now this is going to happen a lot of places. But let's just start with the one that gives me a positive pi over 3. So we have tangent is positive, not pi over 3, positive square root of 3, sorry. And the other option is negative square root of 3. Well, the positive square root of 3 would be here. The next time I get there is down here, because a negative divided by negative would be positive. So that's pi over 3. But for tangent, I only have to go half of the way around the circle to get my coterminal angle. To get a negative square root of 3, they have to be opposite sides. So square root of 3 divided by negative 1, or negative square root of 3 divided by 1. So this one is at 2 pi over 3. So we always list the first one we see. And then we're going to add and subtract, since this one is just halfway around to get to the next one. It's pi in. Now, could you have technically written down pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3, and put plus or minus 2 pi for each one? Sure. But this is a little more concise. So notice with sine and cosine, we add 2 pi. With tangent, we only have to add pi. Now, number 6 is interesting because this is technically a factor, 2 things being multiplied together. And we have 2 things multiplied together to be equals to 0. We set each factor equal to 0. So we have 2 situations. We have cosine x equals 0. And then the other factor is 2 sine x plus 1 equals 0. So this one, this just means when are the x values equal to 0. So x value equal to 0, that's going to happen at pi over 2 and 3 pi over 2. So I could put, well actually this is an x, I'll write x, pi over 2 plus or minus 2 pi n, and 3 pi over 2 plus or minus 2 pi n. That is totally acceptable, but aren't they half of a circle away from each other? So if you wanted to be more concise, this one could actually be written as just half of a circle, and we reach the next one. Either answer is perfectly fine. Next one, solve for sine x. Get sine x by itself, so we would subtract the 1, then divide by 2. So now I want wherever sine is -1/2. Okay, sine is negative. We're down here. So 7 pi over 6 and 11 pi over 6. Now those are definitely not across the circle from each other, so I can't do any kind of shortcuts. I have to list both. Last example. Oh no. This was kind of easy when we had it factored. So I want you to notice that I have a sine x here. Sorry, this is a kind of a highlighter. And then another sine x here. You can factor out the sine x. In other words, we're going to undistribute it, remove it from each of those terms. And I'm going to have cosine x left minus 4. Now we're going to set each factor equal to 0. So sine x equals 0. That's my y value. Equals 0. That happens at 0 and at pi. So we could say 0 plus or minus 2 pi n, pi plus or minus 2 pi n. Or, since they are across the circle from each other, you could just narrow it down and say it's happening every half a circle, every time we go around half the circle. Now the next one, if we solve for cosine x, we get cosine x equals 4. So we're looking for when an x value is 4. Wait a minute. My x value is only a 1 here. 0. -1. I don't ever get past 1 because my radius is 1. So it's never going to happen. So this is a no solution on this side.